Hey, hello, welcome to the show. It's me, JP. It's time for JP's product pick of the week. Thank you so much for stopping by. That is such a bop. I love that song every week. What's going on here? This is it. This is the show. This is the product pick where I pick a thing and I tell you where to go find it, which is that URL or that QR code. You check it out. You can watch this show inside of that product page because the live stream is embedded inside of there. Thank you so much to Jelly and Travis and the new products team for taking care of that, as well as stashing away a bunch of this week's product pick and then slashing the price in half. That's right, in half. So you'll be able to go and pick this up today with no coupon code necessary and get yourself a big whopping 50% off. You can go check it out now, or if you need a little more persuading, I'm going to have Lady Ada tell us about this week's product pick. So please take it away, Lady Ada.
Yay, cowbell. It's time for more cowbell. This is our second cowbell. The first one was the prototyping one. Usually Adalogger is the second board I make for a platform because it kind of covers a lot of stuff. A lot of people want to do data logging and they also just want to have an SD card socket. So this is a cowbell. It goes on a Raspberry Pi Pico board, either the Pico or the Pico W, a beautiful silkscreen penguin, the Adalogger logo that you guys did, you and Bruce did,
Yeah.
and then the cowbell logo. So this is a simple little board that just kind of slips underneath or over a PiCowbell, sorry, PiCow or a Pico, and gives you a real-time clock, the PCF 8523. It's a low cost. It's a fairly good quality real-time clock. You're going to lose a second or two here, but it's inexpensive, and I think that's a worthwhile trade-off. And then to go with the real-time clock, there's also a coin cell holder. We don't include the coin cell because it makes it very hard to ship if you do, so we sell them separately, or you can buy them at your local grocery store. It's a standard CR 1220. There's also a reset button because the Pico doesn't have a reset button, so you can press that. A micro SD slot that fits nicely at the end. It's a Molex pull type, so you pull it out, pull it back in. And then on the other end is a STEMMA QT port for attaching sensors. So this is basically perfectly designed for, you have a Raspberry Pi Pico or Pico W, and you want to log data from a sensor and you want to timestamp it, or you want to read audio files or data files off of the SD card. Maybe you want to do something with timing. It's a 3-in-1 board, but very handy. All the little individual pieces are very inexpensive, but they fit quite nicely together. So, I put together a very quick little demo that, won't look very exciting, but I can still show it
Wow.
off. So this is, oh wait, just turned off the light. Can you hit the autofocus for me? Thank you. Okay, so this is a Raspberry Pi Pico, and I've got it wired up over the STEMMA QT to a BME 280, and then you'll notice that this LED flashes every 5 seconds. I just wrote a little bit of CircuitPython code, or maybe it was Arduino code, I don't remember, that will read the temperature, humidity, and pressure off of the BME 280 through the plug-and-play connector, and then log it to the SD card, and then flush that data to the SD card. We'll publish all that data as well. But if you wanted to, this is stacked on with stacking headers that are soldered in. You can add, a battery connector if you'd like. I think we stock one from Pimoroni that allows you to run a Pico off of a LiPo battery that can then be recharged. So you can take it for like portable data logging, or again, you want to host data that has time, sensor input, and SD card. And then, I did some simple things like if you remove the SD card and then, it says like, hey, you remove the SD card, and it, warns you like your data is not being logged anymore. And then on the bottom, oh wait, that's the prototype one. So let me get the final version. It uses the default, thank you. It uses the default SPI port on Arduino. If you're using the Philhauer core, same with I2C, that's for the QT and the real-time clock. And if you'd like, there's also a SD card detect pin. That pin will short low when a card is inserted, or it's the other way around. Basically, you can use it to determine if there's a card physically inside. You can see the little spring that opens and closes when something touches. And a lot of the pins are also duplicated over here. So, you could get to them. They're also labeled. So if you're like, oh, I can sort of solder a wire if I want to get to other IO pins, or you could, like, as seen here, just solder stacking headers and you put it onto a breadboard or another board that you can get to the rest of the components, the rest of the pads, without being in the way of these components. So that is, oh, and then I'll just show on this prototype I do have, I'll show what the battery looks like. So this is when the battery is installed. The prototype is green. Your version will be black, but the prototype is green. And then once you install the coin cell, it'll keep time for up to 7 years.
Wow.
Wow is right. It is I should say, this week's product pick is the PiCowbell Adalogger. It is for logging your data. It has a micro SD card over SPI. It has a STEMMA QT port for attaching sensors, and it has a real-time clock with battery backup. You can plug in a CR1220 battery into there, and then once you've set that clock one time, you can forget about it. It doesn't have to have power. It'll go for many years and be able to maintain the proper date time stamp, which it will then, given the code that you use in either CircuitPython or Arduino, allow you to track data changes in some kind of a sensor, maybe plugged in over the little STEMMA QT port there, and give you little entries of a comma delineated or delimited or other text file format that you store on the SD card for your sensor data and your timestamps, which is super, super cool. So let me first of all show you the product page for it right there. So that's, as I mentioned, 50% off. It's product 5703. We've got those nice silkscreen graphics on the back, by the way, I wanted to show. There it is. We have most prominent on there the coin cell 1220 slot on there, the real-time clock, and then we have the little port there for STEMMA QT I2C and the SD card reader. As Lady Ada mentioned, that's over SPI, and you can also use if you solder a little jumper on the bottom, you can use the little spring in there that's a switch to do a little SD card detect. If you scroll down in here, you get some more info about it, as well as this show being broadcast from right inside of the page. And you can keep scrolling down and get to some Learn guides. So first, there we have that primary Learn guide, which is that right there. So there we can see the card, we can see the board, we can see example of that stacking up. So there's a few ways to do this. I like that one right there. So here you can see I've got a Pico, I've got the Adalogger, I have soldered in some headers, and then there's not yet soldered in the little sockets. But once you solder that in there with the little short headers, you get a nice little package there that'll do your data logging, and you can still access the SD card and the I2C connectors on the ends. So there's a few ways to do that. You can use stacking headers. You can put them side by side. I'll show you a demo of this in action side by side on a doubler or a tripler. And then you can check out the pinouts here. It'll let you know every pin and how it's used, the ones that are used for SPI as well as I2C on there. And then the section here on real-time clock with CircuitPython, you want to check that out so you can set up your real-time clock setting. Once you've put the battery in, you can forget about it. It'll just be there for you. And you can also do that inside of Arduino. And then we have an example of data logging in both CircuitPython and in Arduino there. If you take a look at the down shooter here for a moment, you can see what I mentioned about doing a Pico, and I should mention this is good for both Pico and Pico 2, Pico W, Pico 2W, all of those will work. Here I've got my favorite little friend, the PiCowbell Tripler. Got the Pico 2, I've got the Adalogger. You can see I have the coin cell battery in there. I have STEMMA QT plugged into an SHT45 humidity and temperature sensor. And then I've got my little SD card plugged in there to log data. And that's actually currently in action. Every 30 seconds you'll see a little LED light up on the Pico. Oh, it just went. It means it just wrote some data. And if we take a look at, go to my code view. Let me hide that for a second first. take a look here at some CircuitPython code. This is based on Liz's example code in the Learn Guide. And you can see the key things here are we're importing SD card I/O, and we're importing the PCF8523 so that we can deal with the real-time clock over also over I2C. And then in the main setups, I have the pins for I2C. We're setting up the sensor, in this case the SHT45, but that could be any sensor that you're using. And then we're setting up the real-time clock. You can set your, I don't need to do this now because I've already done it once, but this little bit of code in here allows you to turn this to true, change your date time. This is not the one I used a separate piece of code, but here you would set that to today's date and the current time, set that to true, save it once, and then you can set this back to false. But it's kind of nice to leave that in there for future you. You'll appreciate it. And then the get temperature here is just all I2C stuff off of that sensor. And then in the initial SD card pass, we just check to see, using this try except here, can we open a file named temp.txt? And then in that, we're going to write the little header information about the time, date, and the sensor that we're using. Then in the main loop here, you can see we are checking the date stamp using RTC date time. We open up that text file. I'm turning on the LED just so I see it start. Getting the temperature using sensor temperature, and then writing to the card. So you'll see the same data down there at the bottom is basically it's slightly different format, but that's 75 degrees, and the time is 1:14 and 18 seconds. Last time that ran, you'll see every 30 seconds that runs through. And then we can error if there's no SD card in there. The data that I'm getting off of there, if we let me turn this little view back on, looks something like this, plotted in this case inside of Google Sheets. So if you look along the side here, this is a few hours. I had this running overnight of the temperature. So this is in Fahrenheit. I've got 73 degrees, 72 degrees, 71, starting to drop through the night. And then in the morning, I put it outside. It was 59 degrees, and then starting to warm up, 60, back up close to 70. And those are the date stamps, or time stamps rather, listed there. So I was just able to grab that data and quickly plot it out so you can use it for whatever you want. And funny thing is, if you are interested in doing some more advanced plotting, we have this nice Learn Guide here from Tyeth, which is plotting offline data, JSON-L to CSV files, filters, and graphs. So you may find some interesting info in there useful for writing to the format that you want on the SD card and then plotting that however you like. And then, oh, someone said we couldn't see the Google Sheet. Thanks for letting me know. Let me make that visible there. I turned it on and then forgot to push that as a new broadcast element. So there you can see that's the same data that I just plotted on the SD card. If I scroll down here, you'll see this is just my imported text or values of temperature next to the time. And then this graph here, I just kind of quickly graphed that off in Google Sheets. If we go back to the browser view here, making sure that shows up for you. Breaking news, I just saw a text over in our Discord chat from Tyeth and Brent. It says, hey, oh, let me show the Discord, in fact, as I announce that. As if by magic, a new release of the beta data logging firmware just landed this afternoon. Whippersnapper offline mode for data logging with an SD card using no code. ESP32S2, S3, RP2040, RP2050. So you can take a look at our Discord. That's at adafruit.it/Discord. Look for the live broadcast chat channel. You'll see these links here. This will take you to the GitHub for this, as well as the updated help guide. And this is a way to program your board, either the ESP32s mentioned or RP2040, RP2350, without using any code and have them store data onto the SD card. So this is probably tailor-made for this very board here if you want to build a no-code data logging project using some of those tools that we've developed for some of the whippersnapper things that are usually considered to be online. Now we have these offline solutions, so go check that out. Go back here, take that off. Product photos here, just to show you another nice look at them. You can see we've got STEMMA QT connector, the chip for the real-time clock, a little reset button on there, which is nice. That will, by the way, if you do, that's I think maybe the only downside to doing the stacking or the sandwiching method is you won't have that reset button accessible, but it's probably not super necessary once you've put this together and are running it maybe in a battery power situation or solar situation, and you're just logging data somewhere remotely. Go retrieve this. If you have to pull it apart to reset it, you still can, because those would be regular headers. But I do like this style of, I've got a battery in this one, in fact, so it'll keep logging. I do like this style of using either a double or a triple PiCowbell proto board here. The extra space gives me somewhere to hook up that temperature sensor. It's all plugged in over I2C. All right, what else? Let me know if anyone has questions about any of that. That is the URL you want to go to go check that out. And let's see, Brent says, yeah, loving the doubler tripler for projects too. It's very convenient. The Picos are cheap enough that you can do some with, you know, sockets on them if you want to plug boards into them and vice versa. But it is still nice to just, if you're using these types of doublers and triplers, both for our feathers and for the Picos, it means just solder male headers on the underside of all your boards, and they can just lay next to each other. That's kind of what I've landed on. All right, let's see. I think that will do it. So let's wrap that up. Once again, the product pick of the week this week is the PiCowbell Adalogger with real-time clock, micro SD card storage, and STEMMA QT connector, all in a neat little Pico and Pico 2 flavored package. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. Thank you so much, and I'll see you next time. Bye-bye.